Hi, I'm Yu. This is first of the series of video on vector space classification. In this video, I will compare linear with nonlinear classifiers. To simplify the discussion, we will only consider two-class classifiers in this video and define a linear classifier as a two-class classifier that decides class membership by comparing a linear combination of the features to a threshold. We will talk about two learning methods here. The first one is naive-based, which is covered in our class. The second one is Rochel, which are introduced in this second video of this series. They are instances of the linear classifiers, the perhaps most important group of text classifiers, and we will contrast them with nonlinear classifiers. In two dimensions, a linear classification is a line. These 5 lines represent 5 examples. These lines have the functional form W1 x1 plus W2 x2 is equal to B. Here, x1 and x2 is the two-dimensional vector representation of the document, and W1, W2 is the parameter vector, together with B that defines the duration boundaries. The classification rule of a linear classifier is to assign a document to some class C if the left part is bigger than B. If the left part is less than or equal to B, then the document is assigned to the complement of that class. By doing this, the boundary is made. We can generalize this 2D linear classifier to higher dimension by defining a hyperplane as we did here. Using this equation, we can apply same concepts in higher dimension space. Let's look at the linear classification algorithm in m dimensions. Linear classification at first seems trivial given the simplicity of this algorithm. However, the difficulty is in training the linear classifier that in dimension the parameter W and B based on the training sets. In general, some learning methods compute much better parameters than others, where our creation for evaluation the quality of a learning method is the effectiveness of the learning linear classifier on new data. It's quite common to have some noise documents in the text classification. A text noise document when included in the training set does not fit well into the overall distribution of the class. It misleads the learning method and increases classification error. Noise documents are one reason why training a linear classifier is hard. When we pay too much attention to noise document when choosing the decision hyperplane of the classifiers, then it will be the inaccurate on the new data. More fundamentally, it is usually difficult to determine which documents are noise documents and therefore potentially misleading. If there exists a hyperplane that perfectly separates the two classes, then we call the two classes linear separable. In fact, if linear separability holds, then there is an infinite number of linear separators, where the number of possible separating hyperplane is infinity. Here comes another challenge in training a linear classifier. If we are dealing with a linear separable problem, then we need a creation to selecting among all decision hyperplane that perfectly separate the training data. In general, some of these hyperplanes will do well on new data, some will not. The decision boundary of KNN, a locally linear segment, but in general have a complex shape that is not equivalent to a line in 2D or hyperplane in higher dimension. There is no good linear separation between the distribution circle and triangle because of the circular escape in the upper right part of the graph. Linear classifier misclassify the escape, whereas non-linear classifier like KNN will be high accurate for this type of problem if the training set is large enough. If a problem is nonlinear and its class boundaries cannot be appropriated well with linear hyperplane, the nonlinear classifiers are often more accurate than linear classifiers. If a problem is a linear, it is best to use a simple linear classifier. Thank you for watching this video. The next video will be the last one of this series about vector space classification. I will talk about classification with more than 2 classes.